Hello everyone. In this video we are going to start exercise 13.4, and in order to solve this exercise you need to know about another figure that's new to you. You have not studied it earlier. It is frustum. A frustum is like this and it is a part of a cone. So for example, if this is a frustum, then you can extend and it will become a cone. So if this is a cone and you cut a plane parallel to its base, means if you cut a plane here, you place a plane here parallel to its base, then you will get a frustum. So you have to learn the formulae of volume, CSA and TSA of frustum, and these formulae are derived from the formula of cone only. In order to find the volume of frustum, what we do is we subtract the volume of this cone from the volume of the larger cone and we get the volume of frustum. Similarly, in order to find the CSA, we subtract the CSA of this small cone from the CSA of the large cone and we get the CSA of the frustum. So these formulas are derived in this way only. So you have to learn them, you don't need to do their derivation. So volume of frustum is given by 1/3 pi h in bracket r square plus small r square plus r into r. Here capital R is the radius of the larger base. Okay, means this is capital R and this is small r. So these are two circular ends of the frustum. The radius of the larger circular end is capital R and the radius of smaller circular end is small r. And this is the height of the frustum. And this is the slant height denoted by small l. So CSA is pi r plus r l. What is the CSA of cone? CSA of cone is pi r l. So from there only we have derived this formula, pi capital R plus small r into l. And TSA is, this is CSA, pi l into r plus r, this is CSA, plus the area of the upper circular end and area of the lower circular end. So pi r square plus pi capital R square. And what is L? L is found by this formula, h under root of h square plus capital R minus small r whole square. So you need to learn these formulae in order to solve the exercise. Now let us move on to exercise 13.4. Now see the first question. A drinking glass is in the shape of a frustum of a cone of height 14 cm. Diameters of its two circular ends are 4 cm and 2 cm. We have to find the capacity of the glass. So glass looks like this, and this is a frustum. So it is given that the height of this frustum is 14 cm. So this height is given to be 14 cm and diameters of the two circular ends are given to be 4 cm and 2 cm. So it means this is 4 cm and this diameter is 2 cm. We have to find the capacity. It means we need to find the volume of the glass or volume of the frustum. So first of all, you write down capital R is the radius of the larger circular end, that is 4/2, that is 2 cm. So capital R is 2 cm and small r is 2/2, that is 1 cm. And h height is 14 cm. So we have to find the capacity of the glass. So capacity of the glass is equal to volume of frustum, because the shape is of a frustum. This is equal to, what is the formula for volume of frustum? It is 1/3 pi h and in bracket you have capital R square plus small r square plus capital R into small r. So now put the values. You get 1 by 3 into 22 by 7 into height is 14. Capital R is 2, so 2 square is 4. You can write directly 2 square is 4 plus 1 square is 1 only plus 2 into 1 is 2. So what you get? Cancel the terms. You get 44 upon 3 into 7. So on solving you will get it equal to 102.66 centimeter cube. So this is the capacity of the glass and this is your answer. Now see the next question. Slant height of a frustum is 4 centimeter and perimeters of its circular ends are 8 centimeter and 18 centimeter and 6 centimeter. Find the curved surface area of the frustum. So suppose if this is the frustum, then it is given that the slant height means this height is 4 centimeter and perimeters of its circular ends are given. Now radius is not given directly, we have to find it. Perimeters are given. So perimeter of the smaller will be 6, so smaller circular end will be 6 and larger circular end will be 18. So perimeter of this circular end is 6 and perimeter of this circular end is 18. Now what you will do, how you will find the radius? What is the formula for perimeter? Perimeter of circle is given by the formula 2 pi r. Now for the smaller circular end you will say 2 pi r is equal to 6 centimeter. It means r is equal to 3 upon pi centimeters. Leave pi as it is. You will be able to cancel it out later on. So leave it as it is. Now for larger circular end 2 pi capital R is equal to 18 centimeters. So from here you get capital R is equal to 18 upon 2 pi, that is 9 upon pi centimeters. So now you have the smaller radius and the larger radius. You also have slant height, that is L is given to be 4 centimeter. Find the CSA of frustum. Now what is the formula for CSA? CSA of frustum is equal to pi L into small r plus capital R. You just need to put the values. Pi L is given to be 4 and small r is 3 upon pi and capital R is 9 upon pi. Now what you will do, you will take LCM. So 4 pi and LCM will be pi only, so it will come out and in bracket you are left with 12. So you will cancel pi and you get 48 centimeters square as the CSA of the frustum. This is your answer. Now see the third question. Now this is the shape of a cap and it is given that the radius of the open side is 10 centimeter. It means radius of this circular end is 10 centimeter. So we say capital R is 10 centimeter and radius of upper base, it means radius of this circular end, it is 4 centimeter. So small r is equal to 4 centimeter and slant height is given to be 15 centimeter. We have to find the area of the material used for making the cap. So the material is on the curved surface area and on the top, on the upper base of the cap and not at the bottom. The bottom side is open. So what you will do, you will say that area of material used is equal to CSA of frustum, or you can say CSA of cap, plus surface area or area of upper circular base. So CSA of frustum, first of all find out CSA of frustum. CSA of frustum is given by the formula pi L small r plus capital R. Put the values 22 by 7 into 15. Small r is 4 plus 10. This is 22 by 7 into 15 into 14. So cancel the terms and you will get it equal to 660 centimeter square. So this is the CSA of frustum. Now you find out the surface area of upper circular base. Surface area of upper circular base, that is equal to area of circle. So what is area of circle? Area of circle is pi r square. I have taken small r because the upper circular base is smaller circular end. So small r is the radius of smaller circular end. Pi is 22 by 7 and now r is 4 into 4. Now on solving you will get it equal to 50.28 centimeter square. Now you can find out area of material used. Area of material used in making the cap is equal to 660 plus 50.28, that is equal to 710.28 centimeters square, and this is the answer. Now let us see the next question. A container opened from top and made up of a metal sheet is in the form of a frustum of cone of height 16 centimeter with radii of its lower and upper ends as 8 centimeter and 20 centimeter. So this would be the shape of the container. So, and what is given? The radius of the lower end is 8 centimeter and radius of the upper end is given to be 20 centimeters. And the height is given to be 16 centimeter. In first part of the question we have to find the cost of milk which can completely fill the container at a rate of ₹20 per liter. So in first part we need to find the cost of milk. It means first of all we need to find the volume and then we will be able to find the cost of milk. And in the second part we need to find the cost of metal sheet that is used to make the container. So for that we need to find the surface area of the container. So let us do the first part of the question. So we will find out volume of the container. So volume of container, the container is in the shape of frustum. So in bracket we can write frustum. So volume of frustum is given by the formula 1 by 3 pi h, and in bracket you have capital R square plus small r square plus r into r. Now capital R is, this is capital R and this is small r and this is the height h. So now put the values. In the question it is mentioned to use pi is equal to 3.14. So here we will use pi is equal to 3.14. So we have 1 by 3 into 3.14 into h is 16 and capital R square. Capital R is 20. So square of 20 is 400 plus 8 square, that is 64, plus 8 into 20, that is 160. So now what you will get? You will get 3.14 into 16 by 3 into 624. On adding you will get 624. So now on solving you will get it equal to 10449.92 centimeter cube. Okay, but it is given that the rate is ₹20 per liter. It means we need to find the volume in liters, but we have in centimeter cube, so you can convert it in liters. You know that I'm doing it here. You know that 1 meter cube is equal to 1000 liter. And what is 1 meter cube? 1 meter cube is equal to 10 lakh centimeter cube. Okay, so this is equal to 1000 liter. And you also know that by unitary method, if 10 lakh centimeter cube is equal to 1000 liter, then 1 centimeter cube will be equal to, it will be equal to 1000 upon 10 lakh liters. So zeros will cancel and you will get it equal to 1 upon 1000 liter. So if 1 centimeter cube is equal to 1 upon 1000 liters, then 10449.92 centimeter cube will be equal to 1 upon 1000 into 10449.92 centimeter cube liters, sorry. So this is equal to 10.449 liters. So it means the volume of the container is 10.449 liters, and if the rate of 1 liter of milk is rupees 20, so 1 liter milk is of rupees 20, then 10.449 liter milk will be of 20 into 10.449, that is equal to 208.98 rupees. So this is the answer of the first part. The cost of milk which can completely fill the container is rupees 208.98. Now you need to do the second part, that is you need to find the cost of metal sheet used to make the container. So what you will do for that you will find the CSA of this frustum plus the area of the base, bottom base, that is area of the circle with radius 8 centimeter, because from the upper part it would be open, it is covered from the bottom. So CSA of frustum plus area of smaller circular end. So area of metal sheet used is equal to CSA of container plus area of base. Base is a circle. So first of all you need to find CSA of container. CSA of container is given by formula pi L into R plus R, and area of the base is the smaller circular end, so it is pi R square. Now first of all you need to find L. Now L is given by the formula under root of R minus R whole square plus H square. Now what is capital R? It is 20 and small r is 8. So 20 minus 8 is 12. So 12 square is 144 plus H is given to be 16. So 16 square is 256. This is equal to under root of 400 and this is equal to 20 centimeter. So the slant height is 20 centimeter. Now you put the value of L here, and pi is 3.14 into 20. Small r is 8 and capital R is 20 plus 3.14 into 8 into 8. Okay, so now from here you get 3.14 into 20 into 28 plus 3.14 into 8 into 8. So what you can take out common? You can take out 3.14 common, and in bracket you have 20 into 28 plus plus 8 into 8, that is 64. So what you get? You get the area of the metal sheet used is equal to 1959.36 centimeter square. On solving you will get this answer. Okay, so this is the area of the metal sheet used. So we need to find the cost of the metal sheet, and what is given? It is given that cost of 100 centimeter of metal, cost of 100 centimeter square of metal sheet is equal to rupees 8. So what would be the cost of 1959.36 centimeter square of metal sheet? It would be equal to 8 upon 100 into 1959.36, and on solving you will get it equal to 156.75 rupees. So the cost of the metal sheet used to make the container is rupees 156.75, and this is your answer. Now let us see the last question of this exercise. A metallic right circular cone 20 centimeter high whose vertical angle is 60 degree is cut into two parts by the middle of its height by a plane parallel to its base. If the frustum so obtained be drawn into a wire of diameter 1/16 centimeter, then we have to find the length of the wire. So what is given is, this is a cone and the height of the cone is 20 centimeter, it is given. So this height is given to be 20 centimeter. Now they are saying that the vertical angle is this angle. So this angle of the cone is 60 degree. And the cone is cut into two parts by a plane parallel to its base to the middle of its height. It means if this is the height of the cone h, then from the middle of this height, it means at this point it is cut by a plane that is parallel to its base, so forming a frustum. So we have to find the this frustum is melted and it is drawn into a wire, then we have to find out that what is the length of the wire. Now what is the shape of wire? The wire will be in the shape of a cylinder like this. So length of wire means we have to find height of the cylinder, given diameter is 1/16 centimeters. So in order to do that, we have to equate the volume of frustum with the volume of wire. So for that we need to know the radius of the upper end and the lower end of the frustum. So first of all we will find the radius. Let this be small r and let this radius be capital R. Now what you will do, if this is the vertical angle, then this angle would be 30 degree. I am drawing it once again so that it is clear. This is the cone and this is the height. This is capital R, and from the middle it is cut by a plane, so this is small r, and this angle would be 30 degrees. So first of all we will find out small r. So you consider this A, B, C, D, E. Okay, we have named the points. So consider in triangle ABC, you take tan 30 degree. Tan 30 degrees is equal to perpendicular. Now if this is this is theta and this would be 90 degree. So what is perpendicular? BC is the perpendicular. So perpendicular, that is BC, upon base, that is AB. Now what is BC? BC is small r. And what is AB? Now if this was the height of the cone was 20 centimeter and it is given that it is cut from the middle of its height, it means this height would be 10 centimeter and this height would also be 10 centimeter. So it means AB is 10 centimeter. So r upon 10, tan 30 degrees 1/√3. This is equal to r upon 10. It means r is equal to 10/√3 centimeters. So let it be like this. Now consider another triangle ADE. So in triangle ADE, you again take tan 30 degree. It would be equal to perpendicular. Now perpendicular will be capital R. So capital R upon base, that is AD. So AD. Tan 30 degree is 1/√3. Capital R, AD is 20. So from here capital R is equal to 20/√3 centimeters. Okay, now we have the value of capital R and small r. So we can find volume of frustum. So you write volume of frustum. It is given by the formula 1/3 pi h, and in bracket you have capital R square plus small r square plus capital R into small r. Now put the values. 1 by 3 into 22 by 7 into height. Now what is the height of frustum? Height of frustum is this height and this height is 10 centimeters. So height of frustum is 10. So into 10, capital R is 20 by root 3 whole square plus 10 by root 3 whole square plus 10 by root 3 into 20 by root 3. Okay, so these are the values. Now what you will get it equal to, on simplifying, 22 into 10 into 100 upon 9 centimeter cube. So you will get it, this term you will get on simplifying, and keep it as it is. You don't need to solve further. Now you find the volume of the wire. The wire is in the shape of cylinder. So volume of wire, that is equal to volume of cylinder. Now what is the formula for finding volume of cylinder? It is pi r square h. Now let this r be r1. R1 be the radius of wire and h dash be the height of wire. Okay, height of cylinder or length of wire. So pi r1 square h dash, pi r square h. So this is equal to 22 by 7 into r1, radius of wire, diameter is given to be 1 by 16. So radius will be 1 by 32. So 1 by 32 into 1 by 32 into h dash means height of the cylinder or length of the wire. Let it be h dash only, we need to find the length of wire. Now this volume of wire will be equal to volume of frustum, because this frustum has only transformed into the wire, it is rolled into a wire, so volume will be same. So what we will do is we will equate these two volumes, this and this, and we will find the value of h dash. So volume of wire is equal to volume of frustum. So what is volume of wire? It is 22 by 7 into 1 by 32 into 1 by 32 into h dash. This is equal to 22 into 10 into 100 upon 9. So from here you will get h dash is equal to 7964.4 meter. Okay, you will get it in centimeter and you will convert it into meter. You can leave in centimeter as well. So this would be your answer. So with this we have completed chapter 13. In chapter 13, in the board exams, you are usually asked questions from NCERT only. So you need to be thorough with the NCERT exercises and examples. You don't need to practice much extra questions from this chapter, but it's up to you. If you want, you can. So with this we have completed chapter 13.